Okay, ladies and gentlemen, in this video, our main focus is going to be defining what congruency is all about, and we're going to be identifying what is known as the ruler postulate, all right, as the ruler postulate. And so, as we kind of take a look into our continued talk about geometry, we are going to start looking at terms known as postulates and theorems and axioms that are going to really start being the foundation for our knowledge of what we use, when we use it, how we use it in different geometric scenarios. So let's first and foremost kind of decide what we're going to be talking about specifically about in this video. In this video, we're going to be defining what a postulate or an axiom is. We're going to identify the ruler postulate. We're going to use the ruler postulate to identify distances, and then we're going to define what congruency is all about. So a postulate, simply put, is a rule that is accepted that does not have to be proven. So there are things that we understand, we're in agreement, we don't have to go out of our way to prove the truth or the validity of these statements. And you may also see postulates known as axioms. Now I will kind of say that through our textbook and through other textbooks, sometimes you see theorems which do have to be proven, all right, as postulates, because they're just been so common knowledge throughout the years, and so sometimes theorems turn into postulates. But we'll just keep in mind, when we say a postulate, we're talking about a statement or a rule that is accepted without having to be proven. The first postulate that we want to dive into is called the ruler postulate. The ruler postulate is super simple. The ruler is just an understanding that it's just measurement, all right? That's really all that it is. And every number that you see on a ruler is called a coordinate, all right? So every number that we see on a ruler is called a coordinate. And what I always kind of like to explain this as is, think about it, if you're measuring anything, and let's say that you're measuring this line segment right here. So if you're measuring this line segment, all right, we obviously can see that in this example, it's an inch, right? There's an inch that we are focusing on with that line segment. But what the ruler postulate kind of allows us to do is to realize that even though I have another line segment here, I measure that line segment is also going to be an inch. And so it doesn't really matter which of our starting points and ending points that we do, that line segment was an inch regardless. Because what we realize in the end is the ruler postulate leads us to know something about distance. And the distance between any 2 points is simply the absolute value of the differences of their coordinates. And so that's why we were able to, before on that ruler, I can sit there and say that the distance, I can go ahead and say that the distance, let me get a different color here. So I can say that the distance between 1 and 2. So if I say distance between 1 and 2, distance between 1 and 2 is, of course, 2 minus 1, which is 1, and the absolute value of 1 is just 1. And what this means is that the distance between 3 and 4, I can go in reverse order, and we know that the difference between 3 and 4, yeah, it's going to be a negative 1. But if I'm talking about distance, distance isn't negative, right? We don't have a negative distance. The distance between any 2 points is the absolute value of its coordinates. And so let's take a look here at just what we mean when we say find the length of a segment. So if I want to know what the length between B and C is, so I can sit there and say that the length between B and C is the absolute value of 3 minus 1, which equals the absolute value of 2, which of course equals 2. But of course we can go in reverse order, and I can say that it's 1 minus 3, which is negative 2, and that gives us a value of 2 as well. And so that's what the ruler postulate allows us to do, go in either order of how we go about it. Same thing for AC. From A to C, I have an absolute value of 3 minus a negative 2, which is really a positive 5. But if I went in the reverse order, negative 2 minus 3 is negative 5 in that absolute value, which of course is also 5. So that's what we talk about when we're referring to the distance of a particular segment. Now, one of the key terms that we are going to learn in part of our success criteria within this video was to identify what congruency is. Congruent segments are simply segments that have the same length. All right, congruent segments are segments that have the same length. Now, there are some extremely important symbolisms that you're going to have to know for the remainder of this course, and that is using our congruency symbol. And so if PQ equals RS, if their distances are the same, we use distances without the bar on top. All right, so we use distance without that bar on top. So we say that PQ equals, because distance is value, so we use an equal sign for value, equals RS. Then you can write that the segment, the figure PQ, is congruent to the figure, the segment RS. So this equal sign with our squiggle on top, our equal sign with our squiggle on top, that is the symbol for congruency. When we're in diagrams, you can see down here, we represent tick marks as congruency in diagrams. All right, so we have tick marks for congruency within diagrams. And if there was another set, so let's say for an example, let's say if I had a rectangle, and we'll talk about rectangles a bunch. But rectangles, the opposite sides are congruent. But you can't also use a single tick mark here. You'd have to use a double tick mark on the opposite sides because you can't say that they are all four congruent to each other because they are not in a rectangle. Of course, we could in a square. So if we have multiple pairs, just add a tick mark every single time. All right, guys, so as we close up here, what I want you to realize is that when we are dealing with a symbol, all right, an actual shape, a figure, we use congruency symbols. When we're using values, we use equal signs.